Hello everybody, this is Ramon Alcarria. Welcome again to this course, Network Control Systems with Arduino, an introduction to technology, programming and robotics. This is module 5, and in this last lesson, we will see how to connect our Arduino platform to the cloud through the same Wi-Fi module we previously used in the last lesson. In the first two exercises, we will use the DWIT platform. For the last one, we will mainly use the IFTTT application, which enables the use of many functionalities related to smartphones and social networks. The first application will be to post sensor data in a cloud repository. We will use for that the DWIT cloud platform. This platform is very easy to use and provides an application programming interface to connect devices, manage received data, and secure connections by following a machine-to-machine approach. This platform can be also used to listen to some events and react if a concrete type of data or data value is received. In order to protect the data, logs can be used. However, this functionality is not free. Cost is very low for testing, but in my opinion, not a bargain to be used for production or medium-sized project. A log is a way to register your data so that no one can override it, and also with the provided key, we ensure that our data is only read by authorized persons or devices. DWIT provides an API to work with logged data. For this project, we will use the same hardware configuration as in the previous lesson. We will use the Arduino Mega, the ESP8266, and the BMP180 sensor. We make some changes to the Arduino sketch. I recommend you to open your last sketch in Arduino IDE and save as new name. The steps for publishing data using DWIT are very easy. You need to define a name for a so-called thing, and DWIT provides you the following URL to publish data. In our example, we will publish some temperature, pressure and altitude data from the BMP180 sensor. We need to compose the previous URL by defining a host, the thing name, and the path. In the loop function, we need to concatenate values of temperature, pressure, and altitude. Once we have the complete URL, we need to establish a new connection with an HTTP GET request. Finally, we need to print the server's response to make sure the request was fine. You have the complete code in the documentation, but as I said before, it is better if you try to figure out the code just with these guidelines. In the serial monitor, you will see the Wi-Fi connection. After that, the sensor reading, the cloud server connection with all the HTTP configuration parameters, and finally, the server's response. The server's response is a JSON object describing the thing ID, the creation date, and the inserted data. If you want to follow how data is inserted into the cloud, DWIT provides a graphical interface with data evolution over time. In order to reach your data, you must specify a tname, the unique thing name that you use in your code. In this second part of the practice, we will receive data from the cloud using the DWIT provider. In order to receive the latest inserted data from DWIT, you can use the HTTP GET request of the figure, being thing the unique thing name you used in your code. To finalize this part, we will implement our Arduino code, the data request, printing the data coming from DWIT in the serial monitor. All data is received in JSON format. In the third part of the practice, we will send push notifications to a smartphone. To do that, we need to perform some steps. First of all, we will install an app in our mobile phone to receive the notifications. In IFTTT web page, we create a new applet. Then connect webhooks and choose trigger. The trigger will be to receive a web request in which we must specify an event name, for example, 10 value. Then we must select the action in that. The action will be to connect pushover. As we install the pushover service in our mobile phone, we can select, send a notification, and finally complete the action fields. In the send pushover notification configuration, we need to specify the information of the registered mobile phone. In the configuration for completing the action fields, we can maintain the title field, but we change the message field, including only one value. Finally, we press the Create Action button and then Finish. We have completed our IFTTT service. Make sure the service is on, and we will trigger the notifications connecting our Arduino platform to webhooks. In order to trigger an event, we need to make a post or GET request to the trigger URL. Information of how to make the request is provided in the settings page, such as the webhook key. GET and POST requests are valid, so you can pass values as query parameters in a GET request or as form variables in a POST request. This content will be passed on to the action in our recipe. IFTTT rules are not constantly checked, so you will experiment a delay in the result. For real-time communication, it is better to use other alternatives such as publish-subscribe protocols as seen with MQTT. Thank you very much for your attention. This is the last video of Module 5. Please do not forget to work on the assignments.